The rise of the engineered wood industry, especially plywood, rests on a foundation that often goes unnoticed. Planted forests, managed like a carefully designed green machine. Unlike natural forests that can take centuries to regenerate, plantations of acacia, eucalyptus, or pine reach harvestable size in just 7 to 20 years. Each hectare usually holds 2,000 to 3,000 trees, staggered in different age groups to ensure a continuous supply, a model that frees the industry from relying on the logging of old-growth forests. Globally, industrial plantations now exceed 290 million hectares, providing more than half of all raw material used for plywood. The cycle is tightly controlled from seed, bred to produce straight trunks with uniform grain, to the nursery stage, then on to maturity in the plantation. Trees are planted in plots with carefully calculated spacing to maximize land use while ensuring light and nutrients are evenly distributed. Throughout their life cycle, they are pruned, fertilized, and protected from pests to optimize every cubic meter of wood. Once ready, harvesting is mechanized. Trees are felled, debranched, and cut into logs. Straight trunks are destined for veneer, while tops and smaller branches become biomass fuel to power the very mills that process the wood. The ecological impact of this model is profound. Without plantation forests, global demand for plywood alone would put immense pressure on millions of hectares of natural forests, ecosystems that need centuries to recover. Instead, the closed-loop cycle of plantations enables rapid renewal, reduces carbon emissions, and safeguards wildlife habitats. That's why each sheet of plywood represents more than an industrial product. It embodies a philosophy of balance, turning planting, harvesting, and regeneration into a sustainable cycle where economy and environment work side by side. When logs leave the plantation, they still retain natural moisture within their fibers. Yet once stacked at the mill, if not carefully managed, they can quickly dry out, crack, and lose their natural resilience. That's why the log yard serves not only as storage, but also as a kind of rest station for raw material. Here the timber is regularly misted or sprayed with water to maintain stable humidity, preventing deformation during storage. These artificial sprays don't just moisten the surface. They balance the moisture between core and bark, reducing splitting and curbing the spread of insects and fungi. From a distance, the log yard resembles a vast reserve, where thousands of trunks lie in neat layers under meticulous care. This preservation ensures each log retains its original quality, safeguarding the stability and strength required to advance into the industrial cycle. Before processing begins, the logs are immersed in hot water basins or placed in steam chambers at temperatures ranging from 80 to 100 degrees Celsius. The heat softens the wood's structure, allowing cellulose fibers to expand and relieving internal stresses, which prevents the logs from cracking. Depending on the species and diameter, soaking can last anywhere from several hours to an entire day. During this period, heat and steam penetrate all the way to the core, creating uniform consistency from the outside in. Once removed from the basin, the logs have reached the flexibility and stability required, ready for precise machining. Once the logs have been softened by heat, each trunk is cut into sections measuring 1 to 2.6 meters in length, depending on the panel size to be produced. Before cutting, the logs are aligned using a laser measuring system or mechanical gauge to determine the optimal length, maximizing usable volume while removing major defects. The ends are then cut flat, smooth, and square to ensure a secure grip when mounted onto the spindle of the peeling lathe. At this stage, the entire log begins to rotate at speeds reaching hundreds of revolutions per minute.